Hello, thank you. Can everybody hear me? Is that good? Woohoo! Alrighty. Yeah. Okay, well, thank you to Graham for warming us up, and that was very inspiring. I thought that was a really cool talk, and it's really good to see, I think, some of the anti-points about what I'm going to be talking about actually happening on real projects that are out there serving customers. Okay, so I'm Len. I'm from Cloud Africa. You can follow me on Twitter. And yeah, I've been doing a lot of crazy stuff all over the map, from embedded software, enterprise systems, did a lot of work in the Java space, and kind of, gave up on it a bit because of a lot of the frustrations that were mentioned about in the previous sessions. And I've recently, for the past 2 years, been trying to live my dream of building my own company and building an entire cloud platform from the ground up. And I think a lot of what I want to talk about today, very briefly, because there's not enough time to get into it, is just some of the problems that we face and why things go wrong. So let me just try and set the stage a bit. So I think our industry it's really crazy, and anybody who tells you that they've kind of nailed it, that they've got a handle on it, you've got to be a little bit suspicious of. Things change so fast. I mean, I was listening to a podcast recently about really the mobile industry, and today I think it's a $1.5 trillion industry, which 15 years ago just didn't exist. That $1.5 trillion that people are spending today on phones, it's kind of mad. Where does that come from, right? And having recently worked with telcos, I can tell you that managing that mobile industry is not going very well. Hands up who gets the correct bill all the time, right? Yeah. So I think we're in a world where complexity is really, it's just insanely out of control. If you're trying to build an application today, the number of things you have to connect to, the number of pieces of technology that you have to look at, it's a world in which Microsoft Access just doesn't even exist anymore. Purely, I think, because it can't solve a lot of the problems we're trying to attempt to solve today. Things have to be online. People want to connect to Facebook and Twitter and Google, and that's just the starting point. Now you've got to figure out what exactly you're going to do with your app and make that work, and choose a technology stack and choose somewhere to run it. And it's a very, very tricky place to be building software today. I mean, the internet it's amazing, but B, it's changed everything that we do. 10 years ago when I started, I was a C programmer. Things were not connected. It was a much, much simpler world. You used to walk around with a disk. Here's the entire piece of software, and I could give it to you, and that was everything you needed to run an entire application. That world is gone. It's quite interesting to take stock of all the stuff I've learned and to realize how much of it is obsolete. I know an awful lot about RS-232 networking or serial port stuff that's just kind of useless. But not that long ago, I mean, here in Midrand and Joburg, there were entire rooms full of modems. You remember that sound that modems used to make, right? Bulletin boards and modems. I mean, where are all the modems, right? There are millions of modems somewhere in someone's garage. It's kind of weird. Doing what? 56K modems. It's kind of mad. Yeah. It's kind of gone. So, I mean, Moore's law is such an interesting thing. If you take a moment and really try to grasp what it means, is that, in 2 years' time, everything's different again. There was actually a study by some group doing these big computational problems, and they realized that, let's say if they bought their hardware today and they worked for 18 months, they'd get a solution. And they realized that if they just waited for 9 months, they just waited half the time and then bought hardware, that they would still finish on time, but under budget. So they were just like, okay, if right now we think it's going to take 2 years, just take a year off and then buy hardware because it'll be so much faster. It'll get done in the same time. And, we can chill out for a year. It'll be cool. So, everybody knows what Moore's Law is, right? Yeah. Before we continue, can I just see a show of hands? Who is a programmer in the room? Awesome. Okay. All right, so the first question as programmers is like, what do we do with our time in the face of trying to solve our problems? Free beer, right? Yes. But hopefully there's a benefit to coming tonight. Hopefully you actually learn something, unlike the other nights where you're just drinking beer. Do not. I fell in love with Unix when I opened a book and it said, never ever log in as root if you are tired, drunk, or stoned. But okay, I'm going to like this operating system. It's like opening paragraph. Got to read this book. As root, when that's a different presentation. All right, so I think one of the biggest kind of time-consuming activities when we should be developing is we instead spend our time talking, right? We're arguing about whether we should use Oracle or not, or whatever. And from my engineering point of view, if it works, who cares, right? If it's in production, it's done. Let's move on. There are 900,000 other things we have to do. But so many times with so many clients when I've been doing consulting, we'll go to meetings, right? To discuss, to talk about whether or not we should do something. I was talking to some of the guys outside. I don't know if you know that company Etsy, Etsy.com. They do these online shops, and their technical stack's a mess, but they love it because it's just great. You just do whatever's needed. That sort of sense of autonomy. If you can write the whole thing in Bash, great, go for it. I love the previous slides, right? We want to automate this whole deployment thing. We don't go and buy a whole tool. We just grab some Bash scripts and stick it under a button, click, let's go. It's done. Moving on, next thing. Benefits are there right away. If you want to script it in Perl, go for it. Ruby, Perl, whatever, it doesn't matter. But what we end up spending our time on a lot of the time is talking about stuff instead of actually doing it and coding. Okay. So there's that fine balance in a work environment as a programmer. We need quiet, right? We need a lot of quiet time to get code out because it's hard. It needs focus and attention. Interruptions are not great. So I think there's some TED Talks about companies who've adopted this practice of having absolutely quiet days. Like every Thursday, there is no talking allowed at all in the office. And they just, it's amazing. They get so much done. People can't wait for Thursday. All work in the entire organization gets done on Thursday. On, the other days we talk about the work. Okay. So I think it's something to think about in your day-to-day stuff is how much of your time gets spent just talking about stuff rather than doing it. Sometimes you can just go and download Jenkins and Sonar and get it running within 2 hours. It's easy. Yep, we spend an awful lot of time planning, right? And what's that saying? Planning's not bad. Plans are useless. Planning's not bad, but I do think we spend too much time planning. Where's the plan? What's going on? And I certainly believe that software development is it's kind of chaotic. It's very, very hard to predict. We can get closer to our goals through doing than by kind of imagining. There is a big gap between what we imagine and what actually happens, right? Some people think they can bridge that gap through plans. Well, maybe not. And that's the whole basis. There's a talk here about agile and lean and all those cool things. But watch out for doing too much planning, I think. And process can like destroy you. It can take all your time. I worked at a research lab, and we were developing like kind of like medical equipment, and it had to become FDA approved before it could be sold on the market. And the process was so onerous. At one stage we sat down and worked out that to do nothing, like literally, I propose we do nothing, it would take us 6 weeks to get through the process. You know, I propose we would do nothing. I'd have to have a meeting. Like, can you guys sign this? Do you agree? It was going to be documented. It's going to be, okay, well, now we have like a plan to do. When are you going to do nothing? Like, just to kind of work this paperwork stack of the process. You know? Yeah, and what we're trying to deliver isn't paperwork. You know, it's actually working code. You know, that Agile Manifesto, I think, sums up like kind of what we're trying to get to. Working code that's in front of customers quickly, like these frequent deployments. You heard in the previous thing about how frequent deployments just changed the landscape. Everybody looked at this differently and said, wow, great, I can get feedback. Everybody's heard of extreme programming, right? Has anybody read Kent Beck's little extreme programming book? It's highly recommended. Just go read it. I think he captures the essence of the kind of principles, the sort of anti-process stuff. And I think it's courage, feedback, and a couple of things like that. But feedback's so important. And when you've got processes that push those feedback points out, then I think you run a risk of not being able to build good software, right? So we're still failing. I think there's a song somewhere in this. After all these years, we as an industry, we've been building software now, since the 50s and 60s. And I think that the stats are horrific. Something like $300 billion a year is just lost. You know, in the previous slides, you saw like 7 years of work, right? Gets to a point where people are seriously considering just throwing the whole thing out. I mean, we don't want to talk about actual money there, but that's a lot of money, right? That's now gone. That's man hours. There's nothing tangible left there. Something like 30%, I think, of projects in the world deliver no tangible output whatsoever. It's crazy, you know, they're abandoned halfway through. We saw a project here, 2.5 years? It was just scrapped. I mean, personally, I've been on many of those. It's hard. If you've worked on those projects, that's really hard when that kind of happens. So this is a recent case. Oregon in the US spent $40 million to do. I mean, you've heard of this whole healthcare debacle going on in the States, right? As of today, no one in the state of Oregon in the US has been able to register for Medicare. Not one person. Okay, and this money is kind of gone now. They have to do something else. Who knows what they're going to do? Crisis mode. But I don't think they're going to be as wise as Graham and these guys were to kind of throw the rule book out and change. That's the hard part. So why does this happen? I mean, we've spoken about talking too much, too much planning, like too much process can get in your way. But let's talk maybe a little bit more technically. Who's seen this book? Anybody? Okay, recommended reading. This is a book from the Microsoft Press, but don't worry about that. The guy's super cool. He studied, I think, 50 or 60 projects and tried to figure out why it didn't work. These guys set out to build stuff quickly, 6 months, a year. They needed to be shipping. And there's a section in this book where he summarizes the classic mistakes that happen in software projects. And it's the most fascinating list to read because you can kind of go through this list and tick them off, right? Yeah, we did that. And these are things that everybody did. So I thought I'd just kind of introduce you to a couple of these, and that's a cool tune. So under the heading of people, some of the classic mistakes that happen in software projects. Heroics, you know. You know that guy who built that whole like section of the system, right? He's not here anymore and nobody can really fix it. But Jeff was awesome, man. Jeff worked 36 hours a day in Perl and he built so much awesome stuff, man. That like runs the entire world, but no one can kind of fix it. Heroes are tricky because you can't be a hero forever. You can't work at that like heroic pace for more than a few weeks before you kind of fall over, I guess, or take up heavy drinking. Who's experienced the second one? Adding people to a late project, right? Project's not going well. You know what we need to do? We'll hire those consultants. We'll get those guys. They're awesome. There's like a month left. We'll nail it, right? Has that ever worked in anybody's experience? No one? But we do that. Hey, that is so common. Noisy, crowded offices. Who works in their own office? Hands up. 3, kind of like 2% here, 1-2%. Yeah, like you need a door that you can close, right? Because you got to load your brain up with, man, it's kind of crazy what you have to load up. Syntaxes and operating systems and editors and languages, and it kind of takes you about 15 minutes to get that stuff in your head, and then you're like asking, what am I doing? Like, right? What's the actual problem I'm trying to deal with? And then somebody just walks in and starts talking to you again. That talking thing's a problem, man, I'm telling you. You should stop talking. There's a great book called Peopleware, which just nails a lot of these things. The furniture police are particularly bad. We were consulting at a large financial institution, and we moved one of the desks around, because it would be better. We could kind of sit close together. And we got a complaint from the furniture police. Said, listen, like you're not allowed to move the furniture around. It's been organized. You have to go through a process, sign some forms. Don't take the partitions down. We're like, dude, we want to talk to the guy sitting across the desk from me. Do not take the partitions down. Yeah, a classic mistake underneath the heading of process. Anybody experienced this, right? Yeah, Because for people who don't work in code and are non-technical, the stuff's kind of easy, right? The users should just be able to register. You work out the interest. You send the shipping order. Dude, like, what's the problem, man? Like 2 weeks. We're going launch in March, man. That we've already printed the marketing material. Tough luck. I mean, I've been on that project, There was already a conference. The insurance brokers were coming. And then we found out about what the project had to do. We're like, oh, that's kind of cool. Presented with the plan. It's like fait accompli, Technology stack was already decided. Although no one on the team knew that particular technology stack. But still, it was, however much time. Needless to say, it didn't work out. Feature creep. We've all experienced that. I was listening to a podcast the other day about Netscape. Remember Netscape, the browser? And they weren't doing really well, and they were trying to figure out how to make money. And they spent a lot of time, like the file print menu, right? And they added an option in the file print menu for a printing service. This was going to save Netscape in somebody's head. And you could go there and you could like hit this file print service, and it would print somewhere. And then like the next day you would get your printout couriered to you. I mean, they seriously spent time building that feature into Netscape. Kind of crazy. Gold plating features. Yeah. How many times have you sat in meetings with people like they kind of front load the requirements? Well, and we'll get this as well, and you should be able to export it as a PDF and CSV and, directly into Excel. Can't we just build in an Excel connector? That would be cool. Like we can have that. Because they know they'll maybe only get 10 or 20% of what they're asking for, so it's just kind of becomes a bad habit. But we'll get all that stuff, We seriously need high availability and failover. And does this thing scale? I mean, that's a big one these days. I mean, we don't really have scalability problems in South Africa. You don't have 50 million people logging onto your service. Okay. There just aren't 50 million people with internet connections in South Africa. It's not, like we don't have real big data problems in South Africa. And we can argue about that later, but unless you have petabytes of data, you don't have big data. If you have terabytes of data, I can store that on my laptop, That's like, you know what I'm saying? There's some problems of like conceptual understanding there around what we're actually asking for. And I think gold plating requirements tends to come in a lot with non-functional stuff. It must be like 100% uptime. End of story. You're like, guys, it's, laws of physics are against us. We can't. You can never have that. No, we have to have it, yes, It's like, it's kind of nuts. All right, so, Rapid Development, Steve McConnell, go get that book, just read it. It's awesome. It's so full of good stuff, just sort of practical things. This guy, does anybody know who this guy is? Rich Hickey. Yeah, he's super cool. Just go watch all his videos. They're kind of mind-bending. Right? I mean, I think my mind has been shifted more by listening and trying to understand what he's talking about recently than anybody else. This is a great quote. If you want things to be reliable, they need to be simple. People need to understand them. Somebody asked the CTO of Amazon why they don't use like kind of clustered databases and all these things. And he said, well, as soon as you get things that are complex like that, then you need these specialists to look after them. Then whenever somebody wants to do something, they need the specialist, and the specialist becomes a kind of blocker in the way. You can't get anything done unless you ask the specialist guy. So they just said, okay, great. Everything is, it just has to be simple. So then somebody said, well, you guys use Oracle at Amazon. He said, sure, but we just use it as a key value store. Like we don't run any like SQL, like, there's no table joins or anything. It's just purely a key value store. So when you log into the website on Amazon.com, it does one query to the database, which fetches a very large XML document. And that's it. There's no further database access after that. That entire XML document is then cached on the web server. Because they've got this principle in Amazon that even if the entire data center is on fire and you're connected to the last web server that's up, they must still be able to take your order. Okay, it's, talk about eventual consistency. We'll figure it out later. As long as we've taken your order, we'll sort it out. And we don't have to worry that like this entire massive network of things is all up in sync online. There's no single point of failure, for example. Anybody who's done distributed systems knows how insane it gets, and the kind of complexity that comes from trying to run these things in production. So I think one of Rich Hickey's central points that's just kind of stuck in my head and becomes more real every time I think about it is easy is not necessarily simple. What we want are simple things. We want simple things that you can manage in production. And if I give you this thing, it should be like simple to understand. Easy things tend to be things that we know well. Oh, well, cool, I'll just write that all in stored procedures with triggers in the database because it's easy for me. I know that stuff. But now we're trying to deploy that into a large environment. It becomes really hard to maintain. Production's no longer simple. And there's a great presentation. Rich Hickey does it way more justice than I'm able to, but it's such a central point. Easy, the essence of easy is things that are close at hand. So we tend to choose things that we know well. Nobody would ever write in Lisp, right? Because that's hard. Although the first ever online shop on the internet was written in Lisp. Did you know that? You know, the first online shop that Paul Graham sold to Yahoo was written in Lisp. You know. And they thought it was simple. So easy, yeah, it tends to be things we know well, and we tend to choose that kind of by default. And often it's not the good choice for the long run. And the second point that Rich Hickey kind of spoke about, and it's come to mean a lot to me, is this idea of accidental complexity. So you take a database and it's kind of growing, and you've got these non-functional requirements. We need to make sure it's highly available and scalable and all these things. So you decide to cluster it, right? And now you find that you actually need two guys just looking after the database the whole time. Because there's this kind of side effect of having a clustered database, is that it's pretty complicated. And somebody's got to read an awful lot of stuff, or you've got to hire a specialist to look after this thing. It's not easy. And you didn't anticipate that. That complexity wasn't obvious. That desire initially to cluster this database was supposed to give you a whole lot of really cool things. But it didn't. Instead, it gave you more people on the team, more things to worry about, more points of failure. You're like, damn, that was an accident. I didn't mean for that to happen. I meant for things to get cooler and simpler, that I could just kind of add nodes to a cluster. Anybody who's clustered databases knows that it doesn't work like that, right? In high availability circles, the relational databases are known as like the unavailability algorithm. Because as your relational database grows, it becomes more susceptible to downtime, right? Because one node goes down, it of course takes the whole thing out. All right, I think those are the main points I wanted to kind of get across in a lightning talk. So thank you. We should be at that place, right?